1680 suggests C double bond O, and 3300 suggests OH. So all of a sudden, when we look at our IR spectrum, these absorptions tell us the potential bonds, C double bond O, OH. Okay, so what does that mean? Well, it could be a ketone with an alcohol. Here's our C double bond O, here's our OH. Or it could be this. It could be a carboxylic acid. We don't know. But all of a sudden, we can certainly break it down. Now remember, infrared is just one technique that we would use to analyze this. Remember, you've already seen some other analytical techniques, but this is one approach to say, okay, well, it could be a ketone and a secondary alcohol, or it could actually be a carboxylic acid. And then you're saying, well, Dr. Baker, you didn't really give me all the information, because presumably it's going to have a stretch maybe around 1100 for that CO bond. It has to have a CO bond if it's got an OH. Okay. Got our CO bond here, CO bond here, so don't forget. So that helps you. So when you see an absorption, you should correlate it to a bond stretch. That bond stretch should then be interpreted as what potential functional group. I want to emphasize potential. It doesn't give you the complete answer, okay? But it certainly leads you to sort of narrow it down from the 20 functional groups we've had to these 3 or 4, which is certainly helpful. So let's take a look at another example. Okay. Here's a molecule, here's a molecule that contains a secondary amine and an ether. So if we have this sample, someone's given it to us, and we say, okay, it's got a secondary amine and ether, I should expect to see a CN stretch, an NH stretch, and a CO stretch, and obviously a CH, something we don't always think about, but it's organic chemistry. Everything contains carbon, hydrogen. So you're going to see something around 2850 to 2960. The CO, 1050 to 1150. The NH, let's see, what do we say? 3300 to 3500. And 1030 to 1230 for the CN bond. So that's what we would be looking for in the spectrum. So when we look at the spectrum, say, oh yeah, it's got that, check. Did we see that absorption? It's check. Did we see this absorption? Yes, check and check. And so, okay, we can sort of say it looks like this is the right spectrum for the right compound. We would then use a secondary technique to confirm that, maybe a melting point or a boiling point, or maybe some GC analysis to further convince ourselves. Remember, one point of reference is not enough, especially if we're talking about analysis of drugs, compounds that are consumed. You need critical analysis for that. So, hope that helps.